Hi, Sophie. Hi, Alina.
It's 6 o'clock.
Hello, Alina. Hi, Sophie. Um, this is the Kahoot link you guys can use for today. And in the meantime, can you guys try solving the warm-up practice questions I have on the whiteboard right now? I'm feeling a little bit sick today, so if you can, do you guys mind talking a bit more? So Alina, would you like to try the first question? So x plus 1 equals 5. Can you try solving what x is? You can, annotate on the screen if you know how to, or you can just type the answer in the chat. Hey, hello Jason. Hello Henry. Glad you guys came. And Ryan's coming in too. If you guys have a camera, thank you, Ryan. As Ryan is currently doing, if you guys can turn it on, I very much appreciate that. So once again, the Kahoot link is in the chat. If you're on spare, you can just sign on in. So Ryan, would you like
Wait,
to
what's the like code for it?
the code?
Uh-huh.
I posted the link in the chat.
I can't use it on this computer. Like, do you know the
Code,
code?
okay, the code is 318943. Okay.
Okay.
Okay. Uh, so Henry, would you like to start the first warm-up question, please? So x plus 1 equals 5. How would we solve that? You can turn on your mic if you have one, or you can type the answer in the chat.
So we minus 1 from 5.
Okay, so we subtract 1 from both sides. So we have
Man,
x plus 1 equals 5. Um, if we subtract 1 from both sides, what do we get on each side, Henry? So what do we get on the left side?
0.
0. Okay, so do I just put a 0? Henry? Or what do I put on the right side then? So 0 equals, so what's 5 minus 1? Henry?
You put 4.
4. Okay, so over here I'd have 0 equals 4. I don't know. Does 0 equal 4? Did I do something wrong? What do you think, Henry?
Wait,
So remember, you did subtract 1. I'm glad you did that. But what happened to the x? Did anything happen to the x?
nothing.
Nothing, exactly. So nothing happened to the x, which is why I'm not supposed to put a 0 here. I can just put an x, because plus 1 minus 1, that cancels itself out. So you get x equals 4. This would be the answer. Thank you, Henry. iPad, do you mind changing your name to your actual name, please? Jason, would you like to try the next question? X plus 3.
yeah, x plus 3 equals x equals 6 minus 3
Okay, so our first step would be to subtract 3 on both sides. Why would we have to subtract 3 on both sides, Jason?
because x plus 3 we just do the opposite is minus.
Exactly. So if we see a positive sign, we want to subtract 3, okay? So we subtract 3 on both sides. And what do I get on the left side, Jason?
3.
The left side. So,
Oh, 0
okay, uh, we have a 0 here again. And then what about the right side?
and 3.
3. So I asked the same question to Henry. Does 0 equal 3?
No.
No. So what happened here? Did we do something wrong? Because remember,
X. We forgot the x.
equal to x. So
We need x
remember,
equals 3, not 0 equals 3.
exactly, it's not 0 equals 3, it's x equals 3. So I learned this from a math teacher, and usually he likes to do this. He likes to draw in a uh an upside down T, and when we're manipulating algebra equations, we always have to be fair, okay? So in math, especially when we're doing algebra and we're like playing around with numbers, we always have to be fair. So in this case, let's say you want to Ryan Lin, can you tell me what you would do in the third problem down here? Ryan? Okay, if Ryan isn't here, Sean, would you like to tell me what I can do with x plus 7 equals 9? Sean?
What?
Uh, so we have x plus 7 equals 9. What do I do over here? How do I solve the equation?
7's top 9?
Okay, so we would have to subtract 7 on both sides, right? If we subtract 7 on this side, then we will also need to subtract 7 on this side, correct?
Yeah.
Okay. So if we do that, what do we get at the bottom? X plus 7 minus 7. The 7's cancel out, right? Positive 7
Yeah.
minus 7, that becomes a 0. But we also need to drop down the x. The x, we didn't touch it. So the x comes down untouched. We have x plus 0, which is the same as x. And what's 9 minus 7?
2.
2. So we get x plus 0 equals 2. And because anything plus 0 is the same as itself, we can just simplify this to x equals 2. Okay, last one. I think that follows the same order of things we've been doing here. Aaron, would you like to try this one? So first of all, we start by drawing in an upside down T, right? Aaron?
Yeah.
Yeah, so what would be our first step? Remember, we need to be fair. So we have a positive 2 on the left side, right?
-2?
Yes, because it's a positive 2, we want to get rid of it. We only want an x on the left side. So Aaron is correct. We subtract the 2 on the left side. And do we just continue? Do we just go like, aha, x equals 2? Ta-da! Is that correct, Aaron?
Yeah.
No, what did I do
No.
wrong? Or how about this? Can you tell me why x equals 2 is not the answer? So let's pretend x equals 2 is the answer, right? Let's pretend I made a mistake. I'm like, oh yeah, x is 2. Yeah, it's 2. How would you tell me I'm wrong?
Because the answer should be 2 and you add something to 2 to make it 2.
Right. So if x has to be some value where you add 2 to get 2. But, if I put x equals 2, then if I throw it back in, right? If I throw this back in here, 2 plus 2 is
4.
4. And is 4 equal to 2?
No.
No. So, yes, Jason?
You didn't minus on both sides.
Oh, of course. I must subtract on both sides. So we see here that I did subtract the 2 on the left side, but I didn't subtract the 2 on the right side. So remember, anytime you do an operation on the left side, you have to do the same thing to the right side. So what should be on the right side, Jason?
What? Right side should be 0.
Right side should be 0, correct. And Aaron, can you verify for me that x equals 0 is the answer?
Yes.
Yes. So 0 plus 2 is simply 2, and that is the answer. So we've done lots of addition problems, and instead of doing this one, let's try this one first. Let's try the x minus 6 equals 11 first. Is it Sophie? Would you like to try x minus 6 equals 11? So what will be our first step?
Oh, wait. I forgot to change my name.
No problem, Garrus. So it's Garrus, right? You're not Sophie?
Yeah, I'm not.
Yeah, okay. So Garrus, after we draw, sorry, I'm a bit sick today. After we draw our upside down T, what is your first step? For x minus 6 equals 11 on the right over here.
Hmm. Hmm. 6.
Okay, so we
Oh,
tackled
wait.
the 6. Yes, you're correct, Garrus. We have to tackle the 6. Why should we tackle the 6 and not the 11? Do you know, Garrus? If you don't know, you can just say, I don't know.
Okay, I don't remember.
You don't remember? So when we're solving these kinds of equations, notice I say equations, we want to do something called isolate the variable. And Jason, you want
You
to say?
forgot to do this one. Forgot to do
Yes,
the
I know. I'm gonna tackle that later. It is a slight bit harder. And I kind of
um
wanted to continue with addition and subtraction for now. All right. So we always want to isolate the variable. Okay. You might have noticed all the variables are on the left side, but if let's say I switch it around, it was 11 equals x minus 6. I think I can actually do that right now. If I change this to 11 equals x minus 6. Let's say I did that. Garrus, what would be your first step this time?
maybe 11.
Oh, so this time you're saying 11. Remember, we always want to isolate the variable. And what that means is we want to force the variable to be by itself. Okay? So what's the variable in this question?
X.
X, correct. Oops. So we know that X is a variable. Okay, this is being difficult on me here. So we know that X is the variable. And who's its neighbor? Like X is X by itself?
It's accompanied by 6, I think.
Yes, it's accompanied by -6. And we don't really like that -6, do we, Garrus?
No, we don't, I
No, we
guess.
don't. Not really. So how do we get rid of that -6? We say, go away, -6. What can we do?
We put it on the side.
Okay, well, how would we,
Where?
throw it over? Like you have some trash. How would you throw it away onto the other side? Notice it's a -6.
Hmm.
So if it's a -6, we want to do its opposite operation, right? So what's the opposite of a negative?
Positive.
Positive. So positive what? Positive,
6.
positive 6. And okay, I do -6 plus 6, I put in x, and I have x equals 11. Is that the answer? Is that the answer, Gears?
Yeah.
Yeah, well, let's try just to check, okay? So
Fine.
let's say x is 11, um, and we throw 11 back in here. What is 11 minus 6?
11 minus 6 is 5, I think.
Is 5. Okay, so 11 equals 5, right?
Yeah.
Are you sure, Garrus?
Wait. Hmm.
11 equals to 5?
No.
No, okay, so we did something wrong here. What did I do wrong? Can someone help me out? Notice I drew the upside down T for a reason. I don't just like waste my time drawing upside down T's for no reason. It's there for a reason. And if you see there's a positive 6 on this side. When we're doing algebra, we have to be fair, right, Garrus? So if I do something to one side, I have to do it to the other side. So what do I have to do on the left side? I added 6 on the right side. What do I do over here? Garrus?
Put 11 there.
Put 11?
Oh.
So if I add a 6, if I add a 6 on the right side, I also have to do the same thing on the left side. Okay? Because in algebra, you have to be fair. Anything you do on the right, you got to do on the left. Okay? So
So,
on the left side, I would have to add what?
11
Not 11, it's add a
or
6.
6.
Add a 6. So remember, we added a 6 on the right. because we wanted to get rid of this -6, right?
Yeah.
To get rid of the -6. So we added a 6. And you
Okay.
can't say, oh, I can add a million on the right side and keep the left side unequal. It's like saying, okay, there are 2 kids. I'm gonna give like 2 pounds of candy to like the right kid, and then the left kid gets nothing. I mean, if you have like a sibling and then you go trick-or-treating next Halloween, you're gonna feel very sad, right? If like a neighbor gives like all their candy to the right to like the first kid who comes, and then every other kid gets nothing, that's not very fair. And you'd probably have a very sad Halloween.
Yeah.
Right. So in this case, we want to be fair. If I give 6 candies to the right side, the left side must also get 6 candies. Okay?
Okay.
So we have -6 and +6, that becomes 0. And then the x, we didn't touch the x, right? So the x,
Okay.
so -6 plus 6 is 0. So we just get x plus 0, or I can just write x. What happens on the left side? Here's
Okay, the left side,
so it's
you
11 plus 6.
you like
11 plus 6 is
oh yeah, 17, I think.
17, correct. So now we think 17, x is equal to 17. But remember the last time we guessed x was equal to 11 and then we were wrong? Well, it's always a good idea to check just in case, okay? So let's check. Garrus, if we plug 17 back in here, what is 17 minus 6?
17 minus 6 is 11.
It's 11. And is 11 equal to 11?
Yes.
Yes, thank you. So we got that question done. Do I have any other volunteers who'd like to try x minus 8 equals 2? Just do the entire walkthrough, okay? I'm not even gonna draw the upside down t. Just tell me what to do. All right. Any volunteers? I think Jason, you had your arm raised for a while. Okay, go ahead, Jason.
I wanted to do the other ones, but okay.
Okay. Well, let's try x minus 8 equals 2 first. That way we know how to work these through.
We can write on there.
I think you can. You might have to change your pen to white. Sorry, to black.
Oh, okay. Give
So,
me a second.
all right,
Okay, I got it.
all right. Let's see. Okay, I see you have x equals 8 plus 2, and then in the end, x is equal to 10. Can you verify that for me, please? So, are you sure x is equal to 10?
Yes.
Yes, so 10 minus 8 is equal to 2. Thank you, Jason. But so in the format that we were doing, where I was drawing all these upside down t's, um, we would. Do you mind if you clear your side of the screen, Jason? Thank you for your participation, by the way. So if we were
Did I
to
get
start
it right though?
getting right,
Yeah, did I get it right?
yes, you did get it right. So if because sometimes I know a lot of a lot of the students here, we might forget, even myself actually, we might forget to do operations on one side
Oh wait,
and
I
to do it
forgot.
on
Wait,
yeah,
we have
yes,
to use the formula.
what formula?
That formula, like plus 8 on this side, plus
Yes,
8 on that.
yes. So
Oh,
in this case, remember first we draw the upside down t. We draw the upside down t, and then the reason we need to add 8 on both sides is to get rid of that -8, right? Is that correct, Jason?
yeah.
Yes. So what do you get on the left side? Okay, do you just have a 0? 0 equals 10? Is that it?
No, X.
No, it's x plus 0 because
I'm just writing because this side is 0. I'm just telling
right.
people
So
that
the -8 and the +8 become 0. But it's actually x plus 0 equals 10, right? X plus 0 equals 10. And since x plus 0 is just x, we just have x equals 10. So in this case, x is equal to 10. Thank you, Jason. Okay, now we're going to be tackling I think some of the slightly harder questions. So if you just eye the 3x equals 9 question, um, uh, Jason, I appreciate your volunteering, but I'd like someone else to try. Sean, would you would you like to try 3x equals 9, please?
So
Have you learned how to solve these yet, or are you
no,
sure what to do? Okay, so fundamentally these questions are the same as like all the addition problems and subtraction problems you've
I
been doing.
didn't learn these yet.
Okay, no problem, Sean. So when we see a 3x, what,
Yeah.
how could you simplify that? Or because remember, if we think back to how we solved all these addition and subtraction problems, every single thing we were trying to do was isolate the x, right? And if we look at the x here, does it have a neighbor, Sean?
Yeah.
Yes, it has a neighbor in the 3, right? There's an annoying 3 stuck on its right ear, and now it's causing problems for us. So how do we get rid of this 3? We can't add a 3 or subtract a 3 or add anything really, because we're not sure what x is equal to. So what's the opposite to multiplication?
Uh, I don't know.
Because we see that 3x, it's 3 times x, right? And if we want to get rid of the 3, we need to do its opposite operation. So if you remember, if I add something, if I want to get rid of it, I would subtract that same something. If I multiply, let's say, let's say I multiply 2 times 7, okay? So what is 2 times 7? Sean?
12.
2 times 7?
Uh, 14.
14, okay? And now let's say I threw 14 back at you and I said I want a 2, okay?
Yeah.
How would I go from 14 back to 2?
You divide.
Divide by 7, right?
Yeah.
So it's the same thing over here. Before we had some value x, and then we multiplied it by 3 to get a 9, right? That's what this equation is showing.
Oh,
So if we multiply by 3 first, what do we want to do next? If to get rid of the multiply by 3.
so multiply by 3.
Yeah, how would we get rid of it?
Uh,
So you saw here that it was multiplied by 7, and to get rid of it, you divide it by 7. So if I multiply by 3, how would I get rid of it?
you divide.
Divide by 3, correct. So I'm going to draw the upside down t once again. I have 3x divided by 3 on the left side. Um, and then what should I do on the right side? Remember, the reason I draw the upside down t, yes, Sean?
Yeah.
What would I have to do on the right side?
You multiply 9.
Not exactly. Remember, don't just like throw numbers blindly, multiply, add, subtract, okay? You need to know what you're doing. So we see that we divided by 3 on the left side, and I know this sounds a bit unfair actually. Well, not unfair, but it doesn't sound nice when you have Halloween candy. But let's say you have a giant Halloween candy pile, and then for kid number 1, you split it into 3 piles. Okay? What about for kid number 2? Are you just gonna have them eat all the candy like in one day?
No.
No. So just to make sure they don't get sick and like get insane amount of cavities, you might want to say divide it into 3 piles, right?
Yeah.
So it's the same over here. I'm using Halloween candies a lot. This probably should have like been saved till next.
Also, you divide this.
You would divide it by 3. So remember, we want to make this fair, right? So back with the Halloween candies, if you divide one kid's candy pile by 3, you would also have to divide the other kid's candy pile by 3. So it's fair. So what's 3x divided by 3, Sean?
3x divided by 3.
Mm-hmm.
Uh,
So here's an easy question. What's 3 divided by 3?
3 divided by 3 is 1.
3 divided by 3 is 1, and what is 1 times x?
3.
1 times x.
1.
You're getting ahead of yourself because x actually happens to be 3. But so remember, 1 times anything is itself. Is that anything, right? So
Uh,
you got 3 divided by 3 is 1, right?
yeah.
And 1 times x is the same thing as
1 times 3.
okay, maybe I should have changed the question a little. Let's make this question a bit different, okay? Because theoretically you're correct because the 9, the answer just happens to be 3. Let's say the answer was 12 instead, okay? And we have the left side, 3x divided by 3. We can write this. We can write this as 3x divided by 3. Okay? So 3 divided by 3, it cancels because you have 3 candies, you have 3 kids. You give 1 candy to each kid, and then every kid has 1 candy, right?
Yeah.
So in this case, what do you have left? You have 1 times x, and 1 times x is the same thing as x, right?
Yeah.
So on the left side, you just have x. What about the right side? Oops. So on the right side, you have 12 divided by 3. And what is 12 divided by 3, Sean?
12 divided 4.
4, exactly. So in this case, 12 divided by 3 would be 4. And our answer is
4.
x equals 4. Correct. How will we how will we verify that x equals 4 is actually the answer, Sean? Like, let's say if we got x equals 5 or x equals 0 or some other crazy answer, how will we verify that this is the actual answer?
Because 12 divided by 3 goes to 4.
Yes, 12 divided by 3 is equal to 4, but what about 3 times 4?
It's you times
What about 3 times 4? Or 3 multiplied by 4?
3 multiplied 4, it's 12.
3 multiplied by 4 is 12. And is that what we have on the top? Or was that our original equation? Does it satisfy
Yeah.
it? Yes. So in this case, we know that 4 is the correct answer. If we, for some reason, got let's say 5, we get 3 times 5 is 15. And 15 is not the same as 12. So we know that 5 would not be the answer. If you get any other answer other than 4, that you wouldn't get the correct answer in this case. Okay, let me change this question up a little. Instead of like 3x equals 12, let's try something like 5x. Wait a second here. 5x equals 35. Okay. Thank you, Sean. You did a pretty good job there. Henry, would you like to try 5x equals 35? Henry? Okay, well, Harvey, I'm really grateful you turned on your camera. Would you like to try 5x equals 35, please? So our first step would be to draw an upside down T, right? What would be your first step? No, your second step, actually. Harvey? Harvey? Okay, I guess if Harvey isn't answering, I'll ask is it Hamza? Would you like to try solving 5x equals 35, please? Okay, I guess we're a pretty silent group today. Jason, I guess I'll have to fall back onto you again.
I don't know the T strategy.
Pardon? Who is that?
It's my first day, so I don't know the T strategy.
Oh,
Wait, so can I
welcome,
do
Hamza.
it or not?
Okay, well,
It's
Jason,
6:30.
Wait,
I'll let you do the question.
you can let Hamza do it.
Okay, well, thank you for letting Hamza do it, Jason. Hamza, if this is your first time, don't worry. So you can, if you don't have if you don't have any idea what you need to do, you can just ask for help either from me. I think there's another Jason, not that just Jason with a smiley face. Who will be able to help you. Okay, so um, what I was just teaching was in algebra you have to be fair. Okay, and because Halloween's coming up, I'm using a lot of Halloween related, candy related, stuff, I guess. So in this case, I like having two kids. Okay, so we have one kid on the left side and one kid on the right side. And uh, what we want to do is we want to isolate x. And what I mean by that is we want this x to be all alone. So in the answer should be x equals something. Okay, x equals some number. And how would we get from 5x to x? Do you know how you can do that, Hamza? Do you know any mathematical operation you can use to get from 5x to x?
No.
No? Well, so I did this example with Sean a while ago. So can you tell me what I'm gonna change the numbers a little. Can you tell me what let's try 6 times 7, okay? It might be a bit hard, but I think you can handle it. Can you tell me what 6 times 7 is?
42.
42. Wonderful. So 6 times 7 is equal to 42. And now I say, okay, you now have the number 42, and then I want you to do something to 42, and eventually I want my 6 back, okay? It's like I gave you a 6, you multiplied it by a 7, and you got 42, okay? And now I'm like, take your 42, do something to it, and now give me back a 6. How would you go from 42 to 6?
Divided by 7.
Divide by 7, exactly. So if we had an original 6, okay, this looks a bit ugly, but if we had an original 6, we multiply by 7, we got the 42, right? You follow along, right? You're following along, Hamza?
Yes.
Yes, awesome. So we take the 40, and then we take that 42 because we multiplied it by 7, right? And to get rid of that multiply by 7, we would have to divide by 7 to get our original answer. You see that, Hamza?
Yes.
Yes. So in algebra, whenever you do an addition, to counter it per se, you would have to like subtract that same number. And as we just saw, if you multiply by something, you would have to divide by that same something to get the original answer. So in this case, if we have some number x, some value x, and we multiply it by 5, how will we get rid of that 5? Okay, so if we multiply by 5, how will we get rid of it? Any ideas, Hamza? If you don't know, you can ask for help. I think Ryan's volunteering, so uh, don't feel too pressured. Hamza, if you don't know, just say you don't know.
I don't know.
You don't know? Okay. Well, Ryan, would you like to give this a try? So if x is multiplied by 5, what would you need to do to get rid of the 5?
So just 35 divided by 5,
Mm-hmm.
which which equals 7, which is the x value.
Okay. I think you're getting a bit ahead of yourself. So we multiplied x by 5 to get 35. So to get rid of the multiplied by 5, we need to divide by 5. Okay? You actually just did that, Hamza. At the beginning, you had a 6, or I had a 6, and you multiplied it by 7 to get 42, right? And then you took that 42, you divided by 7, and you got the original 6, right? You following, Hamza?
Yes.
Yes. So in algebra, the golden rule of algebra is to be fair. No matter what you do to the numbers, you can throw them in a potato machine, a carrot machine, you can throw it under a car, but you need to be fair, okay? If you eat the numbers, if you eat like the left side, you got to eat the right side. If like you shave the left side's hair, you got to shave the right side's hair. It's the same concept. If you give the left side one candy, you got to give the right side one candy. So we divided the left side by 5. What do we have to do on the right side, Hamza?
Multiply by 5.
Well, we divided by 5 on the left side. So if we need to be fair, we have to do the same thing to the right side. Okay? So if we follow your multiply by 5 logic, it's the same as saying, I'm going to take 5 candy away from you and give that away to John. Or that's not very fair, is it? It's kind of
It's
bullying, really. So if I divide by 5 on one side, what do I do on the right side?
Divided by 5.
Divide by 5, correct. So what is 5x divided by 5?
1.
5x, you are correct. 5 divided by 5 is 1, but the x is untouched. So what is 1 times x? Hamza?
X.
Exactly. 1 times x is the same thing as x, so I didn't have to write the 1 times. So the left side is all set. We already have our standard question format. We just need to finish up with the right side. And what do we have on the right side? I can't see very clearly. What do we have on the right side, Hamza?
Uh,
So we had 5x divided by 5 on the left side, and on the right side, it's I think it's 35 divided by 5. So what's 35 divided by 5, Hamza?
uh, 7.
7, correct. So x would be equal to 7. Now let's say we got the answer wrong and we threw in a 0. Okay, how would you check that x equals 7 is actually the answer? Any ideas, Hamza?
Multiply.
Okay, we would need to multiply. By what number though?
5.
By 5. So we can take x equals 7, we throw it back into 5x, right? So 5x is the same as 5 times x, and we now know that x is equal to 7, right?
Yes.
Yes. So 5 times 7 is
35.
35. So I'm pretty sure this answer is correct. Thank you. Just solved your first problem, Hamza. A round of applause, please. Thank you, Hamza.
Thank you.
All right. I think we have time for one last problem. We've been doing, I think, at least 2 or 3 multiplication problems. So let's do a division problem. And since I think this might be a bit new, do I have any volunteers who are brave enough to try this one? X divided by 7 equals 3. Okay, we have Ryan and Jason. I want to ask, oh, now Ziran Zo. Okay, I'll ask Ziran since I think you haven't answered the question yet. So go ahead and tackle this, please. What do we do first? Are you typing in the chat, Jivan? Okay, iPad already has the answer, 21. And that's pretty fast. Can you tell me how you got your solution, iPad?
Okay. X at bit 7 is 3.
Mm-hmm.
7 multiply 3 is no, 7 times 3 is 21.
Okay, so why did you think to multiply a 7? So what's your justification for multiplying a 7? Why don't you multiply by another 3? Because I think you caught yourself by saying 3 times 3 is not the answer. So why is it multiplied by 7?
Mm,
You understand why? So,
don't know.
pardon? No, don't know? Well,
Yeah.
this is actually very important because once you start seeing crazier operations in like higher math, and by crazier operations, I say things like potato machines, carrot machines, air fryers, that sort of stuff. But so instead of a divide by 7, you want to get rid of it somehow, right? And to get rid of the divide by 7, you need to do its inverse. Okay, that's a fancy mathematical term, but in short, remember what both Hamza and I think Sean were doing at the top over here? We had 6 times 7 is equal to 42, and then we had to divide by 7 to get 6, right? What if I started with a 42 divided by 7 to get 6? How would I get from 6 to 42? Do you know, iPad? I forgot your name again. Could you could you tell me again, please?
Jagger.
Could you type it in the chat, please?
Okay.
So if we have a division sign, the opposite sign would be a multiplication, right? So in this case, you are correct. To get rid of divide by 7, we would need to multiply by 7 on both sides. Remember, be fair. So x divided by 7 multiplied by 7, we'd have an x on the left side, and I'm pretty sure 3 times 7 is 21. So down here, we have x is equal to 21. So I've had you say you were typing your name again. What was your name? Okay. Pardon?
I think he left.
Oh, well, that's unfortunate. So that was most of the uh lessons and stuff for today. Do I have any volunteers who would like to try this one? Because after all those warm-up questions, I know it might sound a bit scary that they were warm-up questions, but get can any of you Ryan, would you like to verify that what value of a is the correct answer to a plus 7 equals 11?
4 plus 7 equals 11.
Okay,
Because,
thank you.
can I say the reason?
Go ahead.
Because it's like something plus 7 equals 11, so
Mhm.
it's a plus sign in front. So you just put the 7, here, and it's gonna be like a negative number, like,
Mhm.
and then 11 minus 7 equals 4, and that means 8 equals 4.
Exactly. So you saw that if we wanted to isolate a, we need to get rid of the positive 7, right? And to get rid of the positive 7, we need to subtract a 7. Do it on both sides. Be fair, remember? And then you get a equals 4. What if you try plugging in a equals 3? What happens with say this one over here? So what's 3 plus 7? Jason, you can answer.
Wait, what? I forgot to wait. Excuse me.
What's 3 plus 7?
3 plus 7 is 10.
3 plus 7 is 10, and we know 10 is not the same as 11. What about 5 plus 7?
12.
It's 12. So that also isn't the answer. And uh, if you guess the answer as a equals 4, you do get 4 plus 7 is 11, and you would find that a is equal to 4. But if the numbers get really, really big, you don't like guessing, okay? If you have like lots of random decimals, guessing is a horrible idea. So it's a much better idea if you just do the subtraction, and then actually isolate the variable. Okay, so notice we've actually been doing lots of one variable equations. Okay, and with one variables, it's nice and all, but what if there are like lots of variables?
It's
Okay,
6:45.
what if we had something like okay, what if we had something like this? I'm gonna write this one out myself. Let's say we have 12 R S equals 30 36. And let's make it a little complicated. Let's say R equals -1. How would you solve for X? S. Ryan, would like to give this a try?
So first you just apply r equals -y into the first the left side.
Mm-hmm.
So it's like 12 and -1 s equals 33, and then later on it's -12 s equals 33
36, yes.
and 36, and then you divide 36 to -12
So why do you define 36 by -12?
because to get the value of s,
Mm-hmm.
and then
So
after
if you only want S, if you only want S, you would need to divide both sides by -12, right? So
and
divide
then
both sides by,
then
go ahead.
the answer is it like -3
It
for
is
s?
indeed -3. So S would be -3. Thank you, Ryan. Would anyone like to plug these answers in, just like maybe into a calculator or something, and verify that 12 RS is equal to 36? Jason?
It is.
It is? Okay. So if you do 12,
I also, why do we need a calculator?
well, you don't need a calculator, but like
We have because we don't need to grab it. We have calculators in the computer.
right, but well, for some operation, it is actually much easier to like grab a calculator and then do it right away. So if we can't just manually do this, 12 times -1 times -3, -1 times -3, if you guys haven't learned yet, a negative times another negative is a positive.
It's 4.
3.
I mean 3. It's 3.
3.
Yeah, positive.
So you'd have 12
Positive
times 3, 12 times 3, and 12 times 3, 1 times 2 is 3, 2 times 3 is 6, so you have 36.
Because because if you times it, you just add like subtracting the decimal to the positive.
I think that is correct. I'm not too sure what I heard though, but let's move on. I actually have a video for you guys to watch. Can you guys tell me if you guys can hear it? Let me just play a small
Hour can
part.
change dramatically from
I
hour
can
to
hear.
hour.
You
It
can?
can vary. 1 hour, it might
Can't?
be lunchtime, get
A lot of tips. People might get some big
What about
ticket
now?
items. The next hour, I might not have any customers.
I
I'm
can
working
hear.
in a restaurant.
Okay, thank you. Let's just begin. I think we have enough time for a Kahoot at the end, but please pay attention. This is just a review, all right?
And I'm making $10 per hour. But on top of my hourly wage, I also get tips each hour. So this entire expression, you can view this as how much I might make in a given hour. Now, you might also realize that the number of tips or the amount of tips I might make in an hour can change dramatically from hour to hour. It can vary. 1 hour, it might be lunchtime, get a lot of tips. People might get some big ticket items. The next hour, I might not have any customers, and then my tips might be really low. So the tips part right over here, we consider that, the entire word, we consider that to be a variable. From scenario to scenario, it can change. So for example, in one scenario, maybe it's lunchtime, I'm getting really big tips. So tips is equal to, let's say it's equal to $30. And so the total amount I might make in that hour is going to, we can go back to this expression right over here. It's going to be 10 plus, instead of writing tips here, I'll write 30 because that's what my tips are in that hour. And so that is going to be equal to, it's going to be equal to 40. Let me do that. Let me do it in that yellow color. It's going to be equal to $40. But let's say right after that, the restaurant slows down. We're out of the lunch hour for whatever reason. Maybe the restaurant next door has a big sale or something. And so the next hour, my tips go down dramatically. My tips go down to $5 for that hour. Now I go back to this expression. The total I make is my hourly wage plus the $5 in tips, plus the $5 in tips, which is equal to $15. As you see, this entire expression, the 10 plus tips, it changed depending on what the value of the variable tips is. Now, you won't see whole words typically used in algebra as variables. We get lazy, and so instead we tend to use just easier to write symbols. And so in this context, instead of writing tips, maybe we could have just written 10 plus t, where t represents the tips that we get in an hour. And so then we would say, okay, what happens when t is equal to 30? Well, if t is equal to 30, then we'd have, so what happens when t is equal to 30? Well, then we have a situation, t is equal to 30. This evaluates to 10 plus 30, which would be 40. What would happen if t is equal to 5? Well, then this would evaluate to 10 plus 5, which is equal to 15. Now, I want to be clear. We didn't even have to use t. We didn't even really have to use a letter, although in traditional algebra, you almost do use a letter. We could have written it as 10 plus x, where x is your tips per hour. X might not be as natural. It's not the first letter in the word tips. Or you could have even written 10 plus star, where you could say star represents the number of tips in an hour. But it just might have not made as much intuitive sense. But hopefully this gives you a general idea of just what a variable is. All it is a symbol. All it is a symbol that represents varying values. And that's why we call it a variable.
Okay, fantastic video. Hopefully you guys all understand what tips are by now. Well, and what variables are. But if you guys could log in, well, actually I think I have one more thing I haven't covered yet. It's I've been using this word a lot, and it's called an equation. Okay. Do I have any volunteers? Harvey, perhaps? Would you like to read this section, please? You can pause over here. Or just this first small section. Harvey? Yeah, I think Harvey's Are you ready, Harvey? Okay, all right, I'll let you read it instead. All right.
A equation is a sentence that contains an equal sign. The equal sign tells you that the expression on the left is equivalent to the expression on the right.
Okay, thank you. So we see some examples here where we have 7 equals 8 minus 1, right? Notice it's always an equal sign, not a greater than sign, not a smaller than sign, not a question mark. It's always an equal sign. And, whenever you see an equal sign, the left side is the same as the right side. We have 3 times 4 is equal to 12. This is true. And 17 equals 13 plus 2 plus 2, which is also 17. Okay, you can continue, Ryan.
You mean I need to read the rest?
Sure. You can read the rest if you want, or you can pass it on.
A equation that contains a variable is neither true or false until the variable is replaced with a number. A solution of an equation is a numerical value for the variable that makes the sentence true.
Mm-hmm. So what we've actually just all been doing was we were just finding solutions to equations to make them true, right? The statements, we like them to be true. There are actually lots of false statements, but you do like making the solutions true. I'll finish it off. So the process of finding a solution is called solving an equation. Some equations can be solved using mental math. Okay, so I know lots of you people can just do it without drawing the upside down t's. That is mental math. But if you have like x squared plus 2x plus negative minus 3, that's not the easiest thing to solve. I mean, if you do that sort of math a lot, it'll be more like It'll come quicker, but you still sometimes do need to like go on paper and start writing all that stuff out. So most of what we were doing today was solving some pretty simple equations. But next class we are going to start bringing on the difficulty. Let's begin the Kahoot. Okay, President Jason is first in. I'll copy the link.
I am.
Okay. Let's bring on the music.
Tell me if you're going to start.
All right, I'll give you guys 1 minute. Wow, we sure are creepy today. And I'd appreciate it if you guys all put in your real names. I see most of these names do look pretty real, so thank you. Okay, using it as well.
Could you wait for me for a sec?
All right, no problem. Top G, do you mind if you put in your real name, please? I'm pretty sure you are Garrus, but I'd appreciate it if you change your name to your real name. Okay? Because after this, I will be sharing the results with your parents. So, real names. And for the Ryans, would you like to, like for example, if you're Ryan Lin, just post Ryan Lin. If you're just Ryan, just post just Ryan. Okay. It does get confusing sometimes. Thanks, Garrus.
And the other one.
Okay, I will be beginning. So if you haven't come in yet, apologies. Here goes. I think we just talked about this. Okay, I'm glad most of you got it correct. We just read a section about this. That's why I left it for last, because I know some of you guys may not remember it for the entire lesson. But it is a sentence, a mathematical sentence that contains an equal sign. That way we know left side is the same as the right side. Okay, moving on. Good job, guys. Awesome. So remember an equation, there's an equal sign. Okay, equation, there's equal. Okay, it has like 80% of the word in it. So if you see equation, you know there has to be an equal sign. So 2 plus 7 equals 9. That's the answer. Okay, moving on. Oh, not too sure why lots of people got this one wrong, but you were just supposed to plug 5 into the answer and check if it was correct. 4 times 5 is not 16, it's 20. 10 minus 6 is 4. They're close, but it's not the same. And 15 divided by 5 is equal to 3. So that is the correct answer. Hey, good job, William. Okay, moving on. Oh, sorry. I think most of you guys got that one right. It's just Okay, it is false. You will realize that 15 plus 7, I think, is 22, not 23. Very common arithmetic error.
It's 7 o'clock.
Don't make assumptions. Okay, I think most of you guys got this one right. The others, I'm not sure we would choose 90, but 10, it's a close guess, but 10 times 10 is 100, not 90. Wow, good job, William. Nice. Most of you got this one right. The 6 may have been a miscalculation, I think. Okay, skipping. All right, 27, good job. Moving on. It is 12. Good job. 20 may have been miscalculation, I think. All right. What? Evaluate 3 RST plus 14 when R is equal to 2, S is equal to 4, and T is equal to 6. So this one is pretty hard, actually. Wow. You probably should. Right. Surprising results, I guess. I guess you just have to take your time and work it through. Let's look at the podium. Oh, Hamza, first time. Good job. William, number 2. Okay. And first place, drumroll please. We have Brian. Wow. Good job, guys. Aaron's in second and Zirenzo is 5th. Oops. Sorry, I didn't catch that. But good job to everyone. Good job in particular to William. I think he had like the highest streak throughout. So congrats. And also very good job to Hamza, who just learned this stuff. So good job. I'll see you guys all next week. Prepare for some more Halloween themes stuff. Maybe more candy related things. I'll see you guys all next week. Bye guys.
Bye.
Bye.
Adios.